Hey everybody, welcome back. We're starting Unit 4 today, Quadrilaterals, Kites, and Trapezoids. The objectives for today's lesson is that you can identify the properties of quadrilaterals, kites, and trapezoids, that you can determine missing angle measures, and that you can determine the area of quadrilaterals, kites, and trapezoids. So the first thing we need to discuss today is what is a quadrilateral? Well, when we look at the prefix here, quad, it means 4. So just like triangle, tri means 3, when we talk about quadrilaterals, we're talking about a shape that has 4 sides and angles. So quadrilateral is a really broad term. It means any shape that has 4 sides and 4 angles. So if we look at our examples over here, we have 1, 2, 3, 4. We have 1, 2, 3, 4. You see how all of our shapes here have 4 sides and 4 angles, right? Now, one of the properties of quadrilaterals is that the sum of their interior angles equal 360 degrees. So when we look at our quadrilateral here, angle 1 right here, angle 2 right here, angle 3 right here, and angle 4 right here. If you add all of them up, they equal 360 degrees. That's really important to remember. So if we're given this quadrilateral below, and we're asked to solve for the value of x, well, it has 4 sides, so we know that this figure is a quadrilateral. That means all the properties of quadrilaterals will apply to the shape. In this case, the interior angles of quadrilaterals equaling 360 degrees, right here. So what we need to do is figure out the value of x by writing the equation x plus 100 plus 60 plus 95 equals 360. From there, we can add up our like terms, the 100 plus 60 plus 95 gives us 255. So x plus 255 equals 360. Subtract 255 from both sides, and you get that x is equal to 105 degrees. Right. So take a second and try the student example below. All right, now I want you to think about a kite. Now if you look on the right here, we have an image of a kite that maybe when you were little you used to fly, maybe not. Now this toy kite is in the shape of a kite. The shape of a kite that we mention in geometry has very particular properties. Luckily, they are in that shape. So the teacher definition here is a quadrilateral. So remember, a quadrilateral is a 4-sided shape. So kite is a quadrilateral that has 2 pairs of adjacent congruent sides. That's a lot of words here that we kind of might want to review real quick. So adjacent. Adjacent, we should know, means next to. And congruent means equal. So I want you to take this teacher definition, this mathematical, vocabulary-heavy definition, and write your own so that it makes sense to you, right? A quadrilateral with 2 pairs of adjacent congruent sides. What does that mean to you? Now these kites have 4 unique properties, and then also noting that the properties of quadrilaterals also apply to kites because kites are quadrilaterals. Number 1, kites have 2 pairs of adjacent congruent sides. So adjacent, we know, means next to, and then congruent means equal. What that means is they have this side and this side that are the same, and then this side, which is equal to that side, right? The two green sides, they are next to each other and they are equal in length. That is what the tick marks tell us. The two purple sides are next to each other and they are equal in length. Property number 2, diagonals intersect or they cross at 90-degree angles. And what that means is the diagonal is when you go from one vertex, so here from D, to its opposite vertex, B. And when you draw that line, and then you do the same thing here from A to C, they create your diagonals. And the diagonals cross or they intersect at a 90-degree angle. In other words, they are perpendicular diagonals. We know that perpendicular means 90 degrees. All right. Now the third property is that there are one pair of opposite angles that are congruent. And now the opposite angle that's always congruent is the angle where you have one side and the other side that's not equal to that side, right? So if we look at this side here is shorter and this side here is longer, where they meet, you get this angle, angle C, right? And that angle is going to be opposite angle A, and we know that the measure of angle A and angle C are congruent. Right? So this is where your long side and your short side meet. That angle is congruent to the opposite angle. Now, property number 4. The diagonal between the pair of adjacent congruent sides is bisected by the other diagonal. And this is really, really dense. So let's break it apart one at a time. First, we see the word diagonal. So we know we're talking about those lines that go from A to C and from D to B. Between the pairs of adjacent congruent sides is bisected by the other diagonal. So the diagonal that they're talking about first, the adjacent congruent sides, right here, is going to be, let me use a different color here, that diagonal right there. And that diagonal gets bisected by the other diagonal, which is going to be diagonal number 2, and we'll make that one that pinky color. What that means is that segment AE is congruent to segment EC. All right. And then lastly, all properties of quadrilaterals also apply to kites. In other words, the sum of the interior angles equal 360 degrees, right? And in order to find the area of kites, we use the equation 1/2 D1 times D2, where D1 is your first diagonal and D2 is the second. So you'll always need to know your diagonals in order to determine the area. Now here's teacher example number 2. It asks us to find the measure of angle X and angle Y. Now there's 2 pieces of information that are important in order to solve this question. One is what we know about quadrilaterals having 360 degrees, and the second is that we know that that kites have one pair of opposite congruent angles. Now if we look here, X and Y are the angles where your short side and long side meet. And just to show this real quick, here's our short side, here's our short side, here's our long side, and there's our long side. Where that yellow and green meet, we get an angle and an angle, right? We know that X and Y are therefore going to be congruent. X is going to equal Y. So for the ease of writing an equation, I'm actually going to call angle Y also the value of angle X. So we're going to do an equation, x plus 95 plus y plus 60 equals 360. But here, I'm going to take that y and replace it with x. So we only have one variable we're working with. And then I'm going to combine my like terms. So 95 plus 60 is 155. And then I have 2x. Now I'm going to subtract 155 from 360. And I get 205. And then I will divide, and x equals 102.5. And since I know that x is equal to y, I also know that y will equal 102.5 degrees. And that's my answer. So take a little bit of time and try student example number 2. And now we're going to find the area of this kite. Now there's a couple of things that we need to remember. One of the properties that we talked about is how one of the diagonals gets bisected by the other diagonal. So we know that this 10 right here is going to be the same as this 10 over here, right? Because that is a side that is a diagonal that gets bisected by MK. That's really good. Now we need to figure out what is D1. And that's our first diagonal, which is going to be here. We know that the first part is 8 and the second part is 15. So when we add those together, we get 23. Now our second diagonal is going to be JL. So it's going to be 10 plus 10, which will equal 20. So area equals 1/2 23 times 20, and you get 230. Here, we actually don't have any units, so we'll just write units and squared. So take a little bit of time and try student example number 3. Okay, now we're gonna flip over to trapezoids. Real quick, I want you to go to this website and read the short story, the short poem about trapezoids. Once you read that short story, I want you to go and answer this question for me. Now the teacher definition that we're going to be working with is a trapezoid is, again, a quadrilateral. So again, all the properties of quadrilaterals will apply. That has at least one pair of opposite parallel sides, and we call those sides bases. So they're opposite of each other and they're parallel. The properties that we associate with trapezoids is, first, that it has at least one pair of opposite parallel sides. And to show that, we again use our little parallel symbols. Property number 2, bases are the parallel sides, legs are the other sides. So here, this side would be a base, this side would be a base. That makes this a leg, and this side a leg. Property number 3, the two angles created along a given leg are supplementary. So when we say along a given leg, let's take a look at a leg. There are two angles that it's associated with. Right here, angle C and angle B. So here we can say that the measure of angle C and the measure of angle B are supplementary or equal to 180 degrees. Similarly, along the other leg, you have angle D and angle A. So here you'll have the measure of angle D plus the measure of angle A also equals 180 degrees. They are the angles created along a given leg. And then lastly, all the properties of quadrilaterals apply to trapezoids. So again, the interior angles add up to 360 degrees. Now, in order to find the area of trapezoids, we use the area equation. Area equals 1/2 the sum of the bases times the height. Now, this is really important, what we identify as the height. It is a vertical height. It is the line that connects base 1 to base 2, creating a 90-degree angle. And then again, your bases are the sides that are parallel. Okay, so let's try a couple of teacher examples. The first one, determine the measure of angle J. What I have to do first is identify where are my bases, what are my parallel sides. And I can see here, it's gonna be this one here and this one here. That means this is a base, leg, leg, and base. Then along my leg, I know that my angles are supplementary. So 104 plus J will equal 180. If I subtract 104 from both sides, J will equal 76 degrees. So take a second and try student example number 4. All right, and for our last teacher example, let's find the area of this trapezoid. Again, using our equation, 1/2 the sum of the bases times the height. So we start off the same way. I need to find my bases, so I find where are the sides parallel. Base, leg, leg, base. And then I'm gonna label. I know my base 1 is 6, my base 2 is 8. And now I'm gonna look at my height. And I have a lot of different possible numbers, right? So here we have a 7, a 4, and a 5. But when we look at our equation, we're looking for this height that makes a 90-degree angle with my base. And the only one that does that 90-degree is 4, right there. So here it tells me that my height has to be 4. So area equals 1/2, 6 plus 8 times 4. And I put that together, 6 plus 8 times 4 divided by 2. My area here is 28, and then units squared. So take a second and try student example number 5. Now in the summary section below, take a couple of sentences to summarize all of the information above. There is a lot. I want you to make sure you're looking at the objective and using the proper academic vocabulary. All right, that's it for today, guys.